You did it to me again. Last night, hand on the doorknob, you cracked open one more room and swore it was the strangest one yet. A room where the complete state of a moving thing shrinks down to a single point, where every point is a whole possible motion, where the future itself is a flow, a current, and you watch the world by watching one dot drift downstream. I have thought about almost nothing else all week, and I've come in ready to fight it.
I did crack that door, and I meant every word through the gap of it. Tonight we walk the whole way in, and I've been looking forward to this one more than any night this season. Because if you made me keep one single room out of the whole of physics and burn the rest, I'd keep this one. So come in fighting. It's the only way you ever properly arrive, and frankly, the only way that's any use to the pair of us.
Then here's the fight, planted right on the threshold before I take a step further in. You said every point is a whole motion, and that I flatly do not believe. Not the whole motion part. A point is a spot. It sits there. It doesn't do anything. You can't fold a thing's entire life, all its swinging and climbing and coming home, down into one motionless dot, and have me swallow that the dot is the whole story.
And there's the imprecision, caught, because that line of mine was a touch loose, and tightening it is the first thing to get straight. A point is not a whole motion. A point is the whole state, everything true about the thing at one single instant, frozen. The whole motion is what you get when you let that point move and watch the track it draws behind it. The point is the now. The line it draws is the life.
So you're already walking last night's promise back inside the first 2 minutes.
Tightening it, not walking it back, and it earns the interruption. Hold the two apart with both hands because they love to smear together. One point, the complete state, this instant, nothing left out. One curve, the entire history, past and future, drawn by that point as time runs. Cross those two, and nothing else tonight will sit right. A point is a state. A curve is a story.
A point is a snapshot. A curve is the whole film. Fine, I can hold those apart, and I'll thank you for the correction once I've stopped being annoyed by it, but you've smuggled something enormous in and said it like it was small. Everything true about the thing, in a single point. I want to fight that instead. How can one point hold everything? A point is one spot on a line. You cannot pack all of what a thing is doing into one lonely place.
Then let's find out how many facts it actually takes, the way we always do, with the plainest thing in the world. One ball on one straight track. A single bead on a single wire, nothing fancier. I stop time dead, freeze the whole room, and I ask you to say completely what this ball is doing right now, this frozen instant, everything, nothing left over. How much do you have to tell me?
Well, where it is. That's the first thing. How far along the track it's sitting. But that can't be the whole of it, can it? Because a frozen photo tells you nothing about what happens next. You taught me that the very first night. A snapshot has no future folded into it. So, where it is, and then how it's moving, which way, and how hard. The two of them together.
The two of them together. And that's the whole of it, right there. Where it is, and how it's moving. That pair has a name we've leaned on since the first night, the state. Now, instead of writing that pair down as words in a list, we're going to draw it. 2 facts, so we hand each fact its own direction on a page.
Give each fact a direction. All right, so lay the where it is out how.
Flat, left to right, a plain horizontal line along the bottom. That line is the whole of where the ball can be, spread out sideways. Far left is one end of the track, far right the other, and wherever the ball's sitting is some spot along it. That's the first fact given a home. One axis spent entirely on where.
The track laid out along the bottom, one end to the other, and the ball's spot is somewhere on it. Good. And the second fact, how it's moving, has to go somewhere else, because that bottom line's already taken.
Already spoken for. So the second fact stands straight up, a vertical direction, at right angles to the first. And up that vertical, we mark not the plane speed quite, we mark the momentum, the motion itself from the momentum night, the mass carried along with the moving, the which way and the how much of the going, both at once.
Hold on, why momentum and not the plane speed? Those feel like one fact wearing two hats. Fast is fast.
They're cousins, and for our one simple ball, you could very nearly get away with either. But the right thing to hang up that vertical, the one that makes this whole room's machinery turn, later, is the momentum, not the bare speed. Notice, too, where that puts us. Last night's flat path room was built on where it is and how fast. That was its home ground. Tonight's room is built on where it is and its momentum. A cousin of speed, but the one the gears downstairs are cut for.
So the two rooms aren't the same room. Last night, position and speed. Tonight, position and momentum.
A different floor, holding up a different picture, and both of them equal to Newton, mind. Same answers to the last hair. 3 doors, 1 house. The first night's forces you grind forward. Last night's flat path across a whole journey, and tonight's, this room of where and how moving. Trust me, the width of a hair on choosing momentum for the up axis. We collect on it before the night's out.
Momentum up the side then, and I'll hold you to collecting. So now I've got a flat page. Sideways is where the ball sits on its track. Up and down is how much momentum it's carrying, and which way. 2 directions at right angles, one for each half of the state.
Try the dullest case first to fix it in place. A ball left alone, sitting dead still, nothing tugging at it. Where's its dot?
Not moving, so no momentum, flat on the middle line. Sitting at some spot along the bottom, and it stays there, doesn't it? A dot that never budges. The one boring thread in the whole room.
One for each half of the state. Now the thing that ought to give you a small jolt. Pick where it is, that fixes you somewhere along the bottom. Pick how it's moving, that fixes you somewhere up the side. 2 readings, 2 directions, and together they land you on exactly 1 spot on the page. 1 point. And that 1 point is now the complete state of the ball. The where and the how moving both, folded into a single place you can lay a fingertip on.
Oh, hold on, let me feel that, because it just did something to me. The where and the how moving aren't 2 things I'm juggling anymore. They're 2 readings that together name 1 spot. So the ball, this instant, is that spot. Not the ball is here and also moving so fast. The ball is that 1 point on the page, and the single point says both at once. Everything about it, right now, is 1 dot's worth of place.
1 dot's worth of place. That page has a name. We call it phase space, though the name matters far less than the picture. The whole of what a thing is doing at any instant is 1 point living in it. Not a ball anymore, not a bead on a wire. A single point sitting somewhere in a plane, holding the where and the how moving in the one location.
Right, but now I've gone and turned this thing on myself, and I don't care for the result. Because it isn't only the ball, is it? It's me. Everything I am, mechanically, where I'm sitting, how I'm moving, is, on your page, 1 dot. My whole self, this instant, a single point crawling around some enormous room. My entire life is a dot going for a walk.
Your whole life is a dot going for a walk, and everyone you've ever known, another dot, somewhere else in the very same room. Sit in the strangeness of it a moment. Don't let it pass too fast. It flattens nothing about the living of it. You still feel the swing from the inside. It only gives the feeling somewhere to sit on a page. A room where you are and how you're moving are the 2 facts that name you.
I'm sitting in it, so my objection's dead. 1 point really can hold everything, because everything, for a single ball, was only ever 2 facts. And 2 facts is what a point on a page carries. Fine, I concede the dot, but it's a still dot, a frozen snapshot, you keep saying. So where does the motion come back in? You froze time to draw the thing, now let it run again.
Now let it run. Unfreeze the clock. The ball moves along its track, so its wear changes and the point slides sideways. The ball speeds up or slows, so its momentum changes and the point rides up or down. Both at once, moment by moment. The point doesn't sit still. It travels. It walks across the page, and behind it, if it left ink, it draws a line.
And that line, that's the curve you kept insisting on. The point moving is the ball moving, so the track the dot draws across the page is the ball's whole history, laid out in one still picture.
Its whole history in one picture. Watch the dot alone, and you never think about forces or cranks again. You watch where it drifts. Forward along the curve is the ball's future. Backward along it, its past. The single point is the now. The whole curve is every now the ball will ever have and every now it ever had, threaded onto one line through the room.
Both directions off the one dot, so the past is as pinned as the future. I trace the thread backward, and there's only ever the one way home.
One way home, as clean as the one way forward. The crank never had a favoured direction in its gears, so the thread runs both ways out of your dot. The whole of yesterday upstream, the whole of tomorrow down. One point, and all of time in both hands.
So the snapshot became a film after all. The dot slid, and the sliding is the motion. And I'd guess different starts draw different curves. Put the ball somewhere else, or moving differently, and the dot begins from another spot and wanders off along its own line.
Its own line every time. Start the ball any way you like. Somewhere, somehow moving, and you've dropped the dot at some point on the page, and from there it threads out its one particular curve. Drop it somewhere else, out comes another. Fill the room with starting points, let every one of them go at once, and every dot goes streaming off along its own track.
A whole room full of dots, all sliding at once, each drawing its own line. That's the river. That's the current you promised at the door. Every dot a little drop, every drop flowing its own way, and the room full of them together making a flow. A river of every motion the ball could possibly have.
The river you were promised. Every drop a possible world. This ball started just so, and the current is the whole family of them flowing together, each carried along its own line by the very same law. Stand back far enough and you don't see dots at all. You see a river streaming through the room, every thread of it one possible history of the one ball.
One ball, but a whole river of the lives it could have, LED, turning only on how it started out.
Only on how it started. Nudge the starter hair and you've picked a neighbouring thread. The law does all the rest. The river is every could have been of the one ball, and the real one is only whichever thread you happen to set it down on.
That's a lovely picture, and I want to trust it. But the fighter in me has a question about the water. Rivers do things. They swirl, they split. Two streams run at each other and cross. Do your lines cross? Can two of these curves run clean through the same point on the page?
That's the question everything else leans on, and the answer is no. Never. Two curves can never cross, and the reason is the first night walked back in through this door. A point on the page is a complete state, a where and a how moving, everything about the ball at that instant. Hand the laws one complete state, and they hand you back one future and one past. Locked. The clockwork.
Right. The state plus the rules pins down all of time, both directions. You drilled that on the first night until it gave me a chill.
So picture two curves actually crossing at some point. At that crossing, they'd share the very same state. Same where, same how moving, the identical dot. And yet one thread peels off this way into the future, and the other peels off that way. One state, two futures. And that is the single thing the clockwork will not allow. A state has one future, not a fork of them. So the curves cannot cross. Not anywhere, not ever.
So the river's got rules, no forking paths, no braiding, no two streams knotting through each other. Every drop that passes through a given spot is heading the identical way out of it, because the spot is the state, and the state has one and only one next move. It's the best-behaved river in all creation. It flows, and it's simply not allowed to tangle.
The best-behaved river in creation. Through every single point of the room, exactly one thread runs, aimed one way. Which means, hand me a point, any point, and the flow already knows the whole curve through it, forward and back. You don't compute the future. You find your dot, and you follow the thread it's sitting on. Downstream to every tomorrow, upstream to every yesterday.
So the whole clockwork claim from the first night, state plus rules gives you all of time, has quietly become a picture. Give me a point, and the river gives me the rest. That imaginary all-knowing mind you told me of, the one that could reckon the whole of history off one frozen instant, its job just shrank to drop a dot, trace the thread.
That's the whole of what Laplace's demon was ever asking for, drawn as a map. One point, one thread through it, and all of time already hanging off that thread. It doesn't grind a crank forward tick by tick. It reads the river. Determinism stops being a claim you argue about and becomes a thing you can very nearly see. A room stitched through with threads, one and only one running through each place.
I have to sit with how much lighter that is than the first night. The crank was labour, grind, step, grind, step. The future built one bead at a time. This just hangs there, already drawn, and you read it off. But you've dodged the thing that actually steers it. What bends the threads? What decides the river runs this way here and that way there? Something's shaping the current, or it's only pretty spaghetti.
Something shapes it. And the thing that shapes the entire river is a single quantity spread across the room. Give me one number at every point of the page. One value here, another there, all over, and that whole landscape of numbers steers every thread at once. It's the engine of the flow, and you've met it before. It's an old friend in new clothes.
An old friend, and you've got the naming look on you. Go on, what's the one number you paint across the whole room that tells the river where to run?
The energy. The plain total energy from the landscape night. Motion energy plus place energy. Only now written out in the where and the how moving, so it's got a value at every point of the page. Painted across the room like a height. In here it wears a grander name, after the man who built the picture, the Hamiltonian. But don't let the grand name fool you.
Hold on, I want to nail that, because you slid a big word past me. The Hamiltonian is the energy? The same total I watched hold level all season, motion plus place?
For our systems, yes, the very same. And I want the fence round our systems said aloud. A clock whose rules don't change from 1 hour to the next. Plain, ordinary hills of place energy, nothing exotic. For those, and that is everything this whole season, the Hamiltonian is the old total energy, motion plus place, dressed up in position and momentum. There are stranger systems out at the edges where it parts ways from the energy. Don't carry it there. But in our room, the two are one thing.
Our systems, the ordinary ones, energy and Hamiltonian, the same beast. Noted and fenced. But there's a snag. Last night's number, the flat path one, I had to subtract, motion take away place. And tonight's number adds them back, motion plus place. You flipped the sign on me between 2 nights running.
I have, and it's worth a breath, because the flip is real and it isn't a trick. Last night's score, the one you hunted flat across a whole journey, subtracted, and it lived in where and how fast. Tonight's number isn't that score. It's the plain total energy, the level line you carried out of the landscape night, and that one always added. Different number, different job, different room. One subtracts and scores whole paths. The other adds and steers a flowing point.
2 different numbers for 2 different doors. I'll hold them apart. So I've got the energy painted across the whole page as a kind of height. Now, the actual steering. How does a height painted on the floor tell my dot which way to slide?
In 2 rules, and I'll hand them to you in plain words, no symbols, so you can carry them with your eyes shut. Rule 1. How fast the dot drifts sideways, how fast its wear changes, is set by how the energy leans on the momentum. The harder the energy climbs as you add momentum, the faster the dot runs sideways. That's the first half of the steering.
How the energy leans on the momentum sets the sideways drift. All right, I can hold that. Energy climbing fast as momentum grows, dot scooting sideways fast. And the second rule? How the momentum itself changes.
Rule 2. And mind the one word in it that does all the labor. How fast the momentum changes, how fast the dot rides up or down, is set by minus how the energy leans on the position. Not on the momentum this time, on the position, and with a minus welded to the front of it. That little minus is the whole difference between a river and a puddle, and I'd wager you can't yet see why.
I can't. And the minus is plainly where you're about to spring something. Say it slower. What's the dullest thing the dot could do? So I can feel what the minus saves me from.
Picture a dot that simply followed the slope, ran straight downhill on the energy, the way a marble does when you tip it loose. It would run to the lowest spot it could find and stop dead. A marble rolling to the bottom of a bowl and parking. No flow, no river. A puddle at the bottom, everything drained to the low point and quit. That is what a dot does when it runs along the slope, and the minus is exactly what forbids it. With the minus welded on, your dot is never once allowed to head down the hill.
And the minus stops the draining. How?
The minus turns the drift a quarter turn. Instead of running straight down the energy's slope, the dot is made to run across it, sideways to the downhill, never down it. So it never reaches the bottom and parks. It circles the hill at one height, round and round without end. The minus is precisely what bends, roll downhill and stop, into wheel around and keep going. It's the reason the river runs in loops instead of draining to a puddle.
The dot always cuts sideways to the slope, so it circles instead of descending. And if it's forever circling at one height on the energy, then its energy never changes. It can't. It's pinned to the one height the whole way round.
Pinned to the one height the whole way round. And you've handed yourself energy conservation, drawn as a picture. The dot rides along a line of constant energy, one contour on the painted floor, and never steps off it. The energy holding level all season, that flat line you underlined on the landscape night, is the shape of the thread. It isn't a separate law bolted on. It drops straight out of the minus in the steering.
Let me lock the engine in before I lose it. The 2 rules, plain. Sideways drift, set by how the energy leans on the momentum. Up and down drift, set by minus how it leans on the position. One minus, and the whole river follows.
That's the engine, whole. And now I pay you the debt I've owed since the first hour, on why momentum and not plain speed. Cast back to the momentum night. A push doesn't change a thing's speed, first and truest. It changes its momentum. That's the real shape of Newton's law. A force is the thing that bends momentum. And momentum was the very treasure you found, holds fixed when space is the same everywhere. So it was never a dressed-up speed. It's the thing the world actually pushes on. Position's true partner.
So that's why the pairing shuts into a loop. The momentum sets how fast the position moves. That's rule 1. The push sets how fast the momentum moves. That's rule 2. Each hand turns the other. Pair position with bare speed and there's no clean loop to close. But position and its momentum lock straight into one.
Each hand turns the other, and the loop shuts. That's the honest half of why. Enough to trust the axis. The whole of it I've only teased you with. Position and momentum are the two edges of a little patch that can't be squeezed, and we meet that patch by name before the night's out. Hold it till then. For now, it's plenty that the push moves the momentum, and the momentum moves the place.
So the thing I proved to myself the hard way, night after night, that motion plus place holds level, is, in here, simply the fact that the dot walks a contour and won't leave it. And here's where my ears prick up, because last night you told me a conserved quantity does something particular in this room. You called it a riverbank.
I did, and now you're standing in front of it. A conserved energy is a wall the current is not allowed to cross. Every drifting dot is trapped onto its own contour of constant energy and can never wander off it. The energy pens the river into banks, and each thread runs along its own bank for good. The thing you caught holding still all season is the very wall that carves and shapes the whole flow. The shadow became the riverbank, as promised.
The shadow became the riverbank. All right, I've got a room, a river, an engine that steers it, and banks it can't cross. But it's all still abstract. Draw me one. Take a motion I know cold and show me its thread. Then I'll believe the map's worth carrying.
Then let's take the one you know coldest of all. The oscillator. The block on the spring. The most common motion in the whole universe. The one you swore you understood by the fourth night. Pull the block out. Let it go. But don't watch the block. Watch its dot, on our page. Where it is along the bottom, momentum up the side. And let's walk it round once, slowly, together.
All right, I'm watching the dot, not the block. Start me where I start the block, dragged all the way out to the side and let go from rest. So it's far out along the bottom, big where, and it isn't moving yet, no momentum. So my dot is way out to one side and flat on the middle line, height-wise. Sitting on the axis, far to the right.
Far to the right, on the middle line. Now let go. What does the block do first? And so, what does the dot do first?
The spring hauls it home, so it starts moving, picking up momentum as it comes. So the dot, its where, is shrinking, sliding back toward the middle, but its momentum is growing, so it's climbing, moving left and up at once. It swings off the axis, up into the corner.
Up and inward, both at once. Keep going. It reaches home, the middle of the track, the spring relaxed. From the fourth night. What's true of the block right there, and where does that put the dot?
At home, it's flat out, fastest it ever goes, streaking through the middle. So its where is nothing, dead center along the bottom, but its momentum is at its absolute biggest. So the dot is smack in the middle sideways, and as high up as it will ever climb. It's reached the very top, center along the bottom, peak of the height.
The top of the picture. And it doesn't stop there, because the block doesn't stop there.
It overshoots. Of course it does. Barrels through home and out the far side, squashing the spring now, slowing as it goes. So the dot keeps sliding, past center, out to the left, and its momentum bleeds away as it slows. So it comes down off the top, heading out to the far side and sinking toward the middle line. And then, oh, I see where this is going.
Say it. Where does it go?
It reaches the far turning point, dead stopped, all the way out to the left, no momentum. So the dot is back down on the middle line, far to the left this time. And then the spring hauls it home again, and it runs the whole thing in reverse, dropping below the line now because it's moving the other way. And it comes all the way back around. To where it started, it closes. The dot draws a loop.
It draws a loop. Round and round, without end, one closed ring on the page, and every lap of the dot around that ring is one full swing of the block, out and back. The oscillator, the whole endless rock of it is one dot going around one loop.
Oh, that is absurdly satisfying. I wasn't braced for it. The whole back and forth, all that overshooting and hauling home I spent an entire night on. It's a circle. The dot goes round, and the loop closing on itself is the very fact that the motion repeats. It comes back to the same state, so it comes back to the same point, so it just runs the ring again. The repeating is the closing.
The repeating is the closing. And look what you can read straight off the ring without solving a thing. The two far edges, left and right on the middle line, the turning points where the block stops out on the wall, the top and the bottom of the loop, home, streaking through at full speed, once each way. The whole physics of the fourth night sitting there in the shape of one closed curve. And that ring is a contour of constant energy, the riverbank. The block can't leave the loop because it can't leave its energy.
One thing, though, which way round does the dot travel? It runs one fixed way round, the same way every time. But what decides which way it goes?
One fixed way, always the same. And it's the minus that sets it. Flip that minus and you'd flip the whole river, every loop wheeling the other way. Nature keeps the one sign, so every dot in the room turns the same way. The river has a direction, and it never once wavers.
So the loop isn't only a picture of the motion, the loop is a bank it's trapped inside. It's energy. Give the block more energy to start.
And out comes a bigger ring, further out, wrapped around the same center. Every energy its own loop, all of them nested rings around the middle, like the rings inside a tree. Read a dot's ring, and you've read its energy. The map isn't a drawing of the physics. Down here, the map is the physics. You get the whole motion by looking at the shape of a line.
The map is the physics. All right, I'm sold on the oscillator, and now you're going to make me do the pendulum, because you always do. But let me predict this one before you show me. A pendulum's basically the same deal, isn't it? It swings out and back over the exact same arc, along the identical path. So its picture has to be a line, a back and forth line. The dot runs out along a track and comes straight back along the very same track, out and back over one line.
There's the guess, and it's wrong in a way worth every second it costs to mend. You've been fooled by the very thing we spent the top of the night prying apart. The pendulum comes back to the same place over and over, true. But does it come back to the same state?
The same state is place and momentum. And when it passes through the bottom going one way versus passing through the bottom going the other way, the place is identical but the momentum's flipped, opposite directions. So those are different states, different points on your page, even though it's the same spot in the actual room.
Different points, though it's the same spot in the room. So when the pendulum passes home going right, its dot is up at the top of the page. When it passes that very same home going left, its dot is down at the bottom. Same place, opposite momentum, two different heights on the map. So the dot cannot run out and back along one line, because the going out and the coming back happen at different heights.
So it can't retrace the line. It goes out along the top and comes home along the bottom, because outbound and homebound are opposite momenta, opposite heights, which means it does exactly what the oscillator did. It comes around. It's a loop again. The pendulum's a loop, not a line. I collapsed it onto the bottom axis and forgot the whole up and down of the momentum.
You forgot the hidden direction, the momentum axis, the one that isn't in the room you can see. Everyone forgets it, and forgetting it is why the room is worth drawing. For a gentle swing, the pendulum's thread is a loop, near enough the oscillator's own ring, which is the fourth night's promise made good. Every small swing is secretly a spring. Small swings, closed loops, nested rings, the dot going round.
Small swings are the oscillator all over again, loops and all. You told me they would be. But you said gentle and small about 4 times just then, which with you is never idle. You're fencing something off. What happens when the swing isn't small? When I really haul the pendulum up and give it a proper shove?
Then something the oscillator can never do. Shove it hard enough and it doesn't swing back at all. It goes clean over the top, right over the pivot and round again, whirling like a propeller. It never turns around, never comes home. It keeps going the same way, over and over the top.
And on your page, a dot that's whirling, never turning back. Its wear just keeps increasing, round and round the same way, never reversing. So it never comes back to close a loop. The thread doesn't close.
The thread doesn't close. It rolls straight across the top of the picture, over and over, never turning down to shut itself into a ring. So the map shows you 2 completely different lives in a single glance. Down low, closed loops, the swinging to and fro. Up high, open threads rolling across, the whirling over the top. 2 kinds of motion, and you can tell which is which purely from the shape of the line.
And more energy makes a bigger loop, the same as the spring, right up until there's enough to stop it closing?
The very thing. Feed the swing more energy, and its loop swells wider and wider. Bigger swings, bigger rings, until there's enough to carry it clean over the top, and the ring bursts open into a roll. The loops grow until one day they can't close at all.
Swinging is a closed loop. Whirling is an open, rolling thread, and there must be some line right between them. The last swing before it tips over into going round.
There is one special thread, the exact borderline between swinging back and going over the top. I'll do no more with it tonight than point at it, because it's a doorway into next time. But hold the picture, the whole life of a pendulum, every gentle swing, every wild whirl, and the knife edge between, is a page full of threads you read at a glance. Loops here, rolls there, one border between.
Let me say the whole shape back because it's assembled into something while you were talking, and I want to hear whether it holds together. One point on the page is the complete state, where it is and how it's moving, this instant. Let time run, the point slides, and the line it draws is the whole motion, past and future. The lines never cross, because a state has one future. The energy, painted across the room, steers every line and pens each onto its own bank. And a motion I know, the oscillator, the pendulum, is one clean loop I can read the physics straight off.
You've got it whole and held in the right order. One point, the state. One curve, the history. No crossings, because the clockwork forbids 2 futures from one state. The energy, the engine, the contours, the banks, and the motion a shape you read. That's the room, standing up on its own legs. Which means it's time I told you why I'd build the rest of physics in here. Because so far, I've only shown you a very elegant way to draw things you already had.
That's the objection I was loading, said before I could get to it. It's beautiful, and so what? If it only ever redraws the oscillator I already had cold, it's a lovely painting of a thing I could do already. Give me the reason this room is more than a nice way to picture a Tuesday.
Fair, and I'll not sell you elegance as though it were depth. Elegance on its own earns nothing. There are 3 things you can do in this room you could barely even phrase outside it.
3 things I couldn't phrase before, then make them things, not adjectives. I came in to call a bluff. Start with the first.
The first, then. Forget one dot for a moment. Take a little patch of them, a small blob of neighbouring starting states, all clustered together, a smudge on the page. The ball started roughly here, moving roughly this fast, but you're not sure to a hair. So it's not one dot, it's a little cloud of them. Now let the river carry the whole cloud along.
A little smudge of nearby starts, all flowing at once. All right, and I'd expect the smudge to get pulled about, stretched, sheared, smeared into some horrible long streak, as different parts of it flow at different speeds. Wrung out like a wet rag.
Wrung out, stretched, sheared, smeared into a monstrous thin filament winding across the room. All of that, yes. But here's the thing that ought to stop you where you stand. Through all that mangling, the area of the blob never changes. Not once. You can stretch it thin as a thread and wind it 1,000 times around the room, and the amount of room it takes up stays fixed forever. It can change its shape however wildly it likes. It can never change its size.
Its area is fixed, however badly it's stretched and smeared. So if the river pulls it long and thin one way, it has to get squeezed narrow the other way to keep the size the same. It can never pile up. It can never thin away to nothing.
Never pile up, never thin away. The flow moves like a fluid you cannot compress. Water in a sealed pipe. Squeeze it here, it bulges there, but there's always the identical amount of it. That fact carries a name, Liouville's, and I'll not derive a word of it tonight. But feel what it means. The dots in the room behave like an incompressible liquid. And the moment you have that, you can start doing statistics on whole crowds of them.
Statistics on crowds. Meaning, what? A room so packed with dots I stop tracking any single one?
A gas. A room with countless particles, all bouncing around. You can't follow every dot, and you wouldn't want to. But because the crowd of them flows without ever compressing, you can reason about the whole cloud, how it spreads, where it pools, what's likely, without chasing one thread. That's the doorway into the physics of heat and gases and probability, the statistics of enormous crowds. And it opens straight off this one fact. The river can't be squeezed.
So the first reason this room matters is that the river's incompressible, and that one fact is the seed of the whole physics of crowds and heat. Fine, that's one. You said 3.
The second you've already felt, so I'll only name it. This room is where the clockwork stops being a slogan and becomes a picture you can point at. The first night's whole audacious claim, the state now plus the rules, is all of time, is only this. One point, one thread through it, every tomorrow and every yesterday already drawn along the thread. Determinism made visible. You needn't take the clockwork on faith anymore. You can see the threads.
1 point, 1 thread, all of time hanging off it. Determinism you look at instead of argue over. That's 2, and you've saved 1, and you've gone quiet in that particular way. So the third is the one you actually brought me in here for. Out with it.
The third is where the whole room cracks open. Everything we've drawn tonight rests on one quiet assumption I never once flagged, that a state is a sharp point, that you can pin down the where and the how moving both together perfectly to a single dot with no width to it at all. And that assumption, the sharp point, is the one thing the real world will not permit.
Won't permit? But that's the whole picture. The complete state, one exact point, everything true at once. You spent an hour selling me the sharp dot. Now you're telling me it isn't real?
Now I'm telling you, it's the one idealization in the room. In the real world, down at the bottom of things, you cannot pin both the where and the how moving to a perfect point at once. Push the position to a needle-sharp value, and the momentum smears out. Pin the momentum, and the position blurs. You're never allowed both razor-sharp together. So a state isn't a dot at all. It's a little blob, a smudge of a smallest possible size that you can never shrink away to nothing.
A smallest possible blob. So the sharp point, the thing this whole room is built out of, is a beautiful lie? Real states have a flaw on how small they'll be squeezed.
A flaw you can never dig beneath. Sharpen the blob whichever way you like. It shrinks in one direction only by spreading in the other, so its little area never drops below that smallest size. It cannot be a point. And notice, that's the same incompressible smallest patch you just met with Liouville. Only now it isn't the fuzz of your ignorance. It's built into the world. There's a smallest grain to phase space itself, below which the sharp point is simply the wrong picture.
So which is the true picture then? The dot or the blob?
The blob. The dot is what the blob looks like from far enough off that its width simply vanishes, the way a whole town is one speck from high enough up. Down at the bottom, the state has a size. We only ever drew the speck.
So the classical dot is what you get when that smallest grain is so tiny, next to everything I deal with, that I never notice it, and I draw it as a point. But it was always a blob. That's the door into the quantum, isn't it? You've stood me in front of it again.
In front of it, and not one step through, because through it is a whole other year of nights, and I'll not pretend tonight explains it. Only this much. The sharp classical state, the exact point, is the large, slow, everyday shadow of something that, down at the bottom, is a blob that will not be shrunk. The uncertainty, they call it. It opens right off this room. Same page, same where and how moving, only the dot has a smallest size.
And you're sure you're not quietly smuggling the whole quantum in through the back door while I'm tired?
The reverse. I'm refusing to. One claim only. The dot has a flaw it can't go under. Why that is, and all it means, is next year's work, not tonight's. But mark that the door is here, on this very page.
So the same room, the same page of where and how moving, is the doorway to all of it. The clockwork lives here, drawn as threads. The physics of crowds lives here, in the incompressible river. And the quantum lives here too, in the fact that the dot has a smallest size it won't go under. One room and it's underneath all of them.
One room, underneath all of them. And that's the reason I said I'd build physics in here. It isn't that phase space is a clever way to draw a pendulum. It's that determinism, the statistics of heat, the door to the quantum, and one more thing, next time, all of them speak the same language the instant you draw them in here. Where it is and how it's moving, a point and a flow. Learn the room, and you've learned the floor under an enormous amount of what came after.
Let me count them on my fingers, because it's a great deal to fall out of one page. Determinism, the threads, heat and crowds, the river that won't be squeezed, the quantum, the dot with a flaw under it, and one more next week.
4 great rooms of physics, and one floor holding up all 4. That isn't a picture of mechanics. It's very near the ground the rest of it got built on, which is the reason the last of your 4 is the one I've been saving.
You said one more thing next time, and you said it the way you always say it. Quiet, with a door somewhere behind you in the dark, winding up to fling it open and stride off, and leave me squinting after you into the black. So, it's the last night next. Where are we going?
Back to a promise from the very first night. Do you remember? I told you the clock could be flawless, and your grip on the starting instant never quite is. And I made you hold a phrase, a slightly different start. I said the whole last night would be about nothing else. Well, we're here, and this room is where you'll finally see what a slightly different start does.
The 2 dots are whisker apart. I remember. 2 starts near enough identical, too close to tell apart, and you said sometimes their futures stay snug together forever, and sometimes they blow apart and share nothing. And I couldn't picture how both could be true inside one clockwork, but in this room, I could watch it, couldn't I? 2 dots dropped a hair apart.
2 dots dropped a hair apart, and you set the river running, and you watch. For the oscillator, the clockwork we know best, the 2 threads run side by side forever, a hair apart the whole way round the loop, faithful as anything. Start close, stay close. The clock keeps its word.
And that's the clockwork behaving. 2 neighbours that stay neighbours. But you didn't get the door look for the well-behaved case. So there are rooms where the 2 threads don't stay a hair apart.
There are rooms where the 2 threads, dropped a hair apart, peel away from each other. Slowly at first, then faster, Then wildly, the tiny gap doubling and doubling until the two dots are flung to opposite ends of the room and share nothing at all. Same law, same tidy no-crossing river, and yet two neighbours that started a whisker apart end in completely different worlds. That peeling apart carries a name, and it's the last night's whole subject.
Chaos. That's the word, isn't it? And it's not the clock breaking. You were fierce about that the first night. The river still flows. The threads still never cross. Every dot still marches one and only one future. It's all perfectly determined. It's only that two starts too close to tell apart run away from each other so fast that knowing the present to any fineness still loses you the future.
Determined and unpredictable, in the very same breath, the two words that felt like a flat contradiction on the first night. And this room is where they stop contradicting, because you'll see them both at once. The perfect, no-crossing flow, and two threads inside it racing apart. The clock never cheats, but your grip on the starting point is never infinitely fine. And in those rooms, that's enough to lose everything. That's where the Clockwork Universe finally meets its own edge.
And those two runaway threads, even as they fly apart, they still can't cross? Still one future apiece?
Still one future apiece, still never crossing. And that's the sting of the whole thing. Nothing lawless happens anywhere. Every dot obeys the same tidy river to the letter. And it's still hopeless to call, because you'd need the start pinned finer than any hand could ever pin it.
The clockwork meeting its edge. After 11 nights of the clock keeping its every promise, the last night is the one where it keeps every promise, and you still can't see tomorrow. That's a hard thing to hold. I can feel it's going to itch all week, which I suspect is rather the point.
It's the point. 11 nights building the most faithful machine there is, and the last night finding the one place its faithfulness stops being any use to a creature that can't measure to infinity. The river that tangles. Next time, the last night, where two threads a whisker apart peel away and take the future with them. But that's next time, not tonight.
Then let me gather this whole night into my arms before you go opening the last door of all, because something's rearranged itself right through me and I want to see whether I can hold it in one piece. You took the thing I feel from the inside, the swinging, the rushing, the whole lived motion of a thing, and told me all of it, at any instant, is one point on a page. Where it is along the bottom, how it's moving up the side. And then you let time run, and the point slid, and the line it drew was the entire life of the thing, past and future both.
Held whole and held right. And you've the rest of it too, I know. The river that never tangles, the energy penning each thread onto its bank. The one clean loop you read the physics straight off. The map was the physics. That's the sentence I'd send you home on if I only got the one. Now, the ritual. You get the last word at the door. Hand me the image. What is it you're carrying out of this room?
The point. That one lonely dot, sitting somewhere on a page of where it is and how it's moving, holding in a single place I can lay a fingertip on, the entire truth of a thing at one instant. That's the one I'm keeping. Because I walked in here dead sure you couldn't fold everything a thing is doing into a motionless dot, and you didn't argue with me. You drew two axes and put my whole self on the page as one point crawling through a room. And then you let the room flow. And when it flowed, everything I've spent this season learning turned out to already live in here. The clockwork was a point drifting a thread. Energy holding level was a dot too polite to leave its contour. The whole physics of heat waited in a river you can't squeeze. And the door to the quantum was hiding in the one thing I'd never once questioned, that the dot was ever truly a point and not a blob with a smallest size. So the next time I watch anything move, a ball, a swing, a planet, my own self crossing a room, I'm not going to picture the motion anymore. I'm going to picture the dot. 1 point in a room of where and how moving, with a whole river already drawn through it. Every tomorrow it has, and every yesterday threaded onto the one line it was always quietly riding.